All right, in this lesson, I'll take you through the process of setting multiple values in a data frame. And the way this will work is we'll set all of the values where a condition is true to a brand new value. So let me take you through the process. I'll begin by executing our import code to bring in our James Bond data set. And let's actually preview all of Bond below so we can take a look at it. So let's say I want to perform this operation. Throughout my actor column, I have plenty of occurrences of Sean Connery. Sean Connery was the first actor to play James Bond. Let's say I want to change all occurrences of Sean Connery in the actor column with a new string, which is Sir Sean Connery. So how do I accomplish this process? Well, there's the proper way to do it, but I actually want to put that off until a little bit later, and I'm going to show you the way that I originally did this and when I was first introduced to pandas and why it's incorrect. So let's begin by actually creating a Boolean series of trues and falses for the value of Sean Connery in the actor column. So I'm going to extract my actor series right here in square brackets. And I want to compare the values to the string of Sean Connery. So I'm going to do equals equals Sean Connery. This is going to give me a Boolean series. A true value will exist for that row if it's equal to Sean Connery, a false otherwise. So now I have a Boolean series that I can use for the purposes of extraction. And I'm going to assign this to a variable called mask. This should all be pretty familiar by now. So my original thought process when I was starting was simple. I would tell myself, okay, so I have Bond, which is my data frame, and I want to pull out the rows that are equal to Sean Connery in the actor column. So I would use my square brackets, which we know we can use to extract rows by feeding a Boolean series within there. So I would feed in my Boolean series, which is mask, and I would get this new data frame, and I would say, oh, that's great. Now what do I want to do? Well, I want to take the values in the actor column, and now I would extract the actor column from this data frame by passing in that column name in square brackets. So after this data frame is returned, I can do actor. That would give me a Boolean series of the rows where we have Sean Connery, so you can see them all present here. And then I would reset this with the equal sign to Sir Sean Connery. Now when I execute this, we're going to get a big red warning box, and I'm going to explain why in just a second. So let's take a look. So we're getting this red warning, and it tells us that a value is trying to be set on a copy of a slice of it from a data frame. So, and by the way, if I take a look at Bond, this is the most critical component. If I preview Bond, which is our original data frame, you can see here that our values have not been changed. You can see Sean Connery is still present here, not Sir Sean Connery. So what happened? Well, I'm going to take this little part out, this part at the end where I extracted the actor column, and let's say I just do this. So now I've extracted the rows where Sean Connery is the value in the actor column. What this is actually giving me whenever I use this bracket syntax is a brand new data frame. It's basically a copy. It takes the rows that are equal to Sean Connery, it extracts them out, and then it creates a copy of that and passes it along to me. And that creates separation from the original Bond data frame. In fact, I can prove this by repeating what I just did, except I'm going to assign this new data frame that we see below to a variable like df2. All right, now once again, I'm going to take df2, I'm going to extract the actor column, and I'm going to set these values to Sir Sean Connery, and I'm going to preview df2 immediately below. So you can see my values in df2 have been modified, but my values in Bond, which is my original data frame, have remained the same, Sean Connery, as we can see right here. So what is happening is it's basically creating a copy of a slice from a data frame. So it's taking out a slice or a subset. It's taking out those rows where the actor value is equal to Sean Connery. It's making a copy of that that's a separate object from our original Bond data frame, and it's modifying the values in that second data frame. That's why df2 has been affected, but Bond has not. And many times this will not be the operation that we want, because we may think that we may have actually modified our original values, but really we've just modified them in our second data frame. And if we haven't stored this in a variable, in this example I did, but if I just did our first example where I did bond mask followed by actor equals Sir Sean Connery, and that whole result wasn't even stored in a variable, then that operation would basically be as good as gone. We would take a copy of our original data frame where the rows were equal to Sean Connery. We would change them to Sir Sean Connery, and then we would throw that data frame away because it's not stored in a variable. And neither our original data frame would be unchanged. Our original data frame would still have Sean Connery, and that new one that we just generated would be thrown away. So that syntax is basically useless. So sometimes you do want to make a copy. Sometimes you want to create a copy like this of a subset and perform a bunch of operations on it and know that you are not affecting the original values. And sometimes that is exactly what you want. df2 here is totally separate and will not affect bond. But if you want to change the values in the original data frame, we're going to have to use a slightly different syntax approach. So I'm going to remove this cell. And what I'm actually going to do here we have bond, is I'm going to call the ix method. And I'm going to begin with those square brackets that we're now familiar with. And usually this would be the point where we give it something like a row label. We would give it something like, a view to a kill here and get a result. So this is just a review of the previous lesson. There we have that series. But what's cool about ix is that you can actually give it a different argument for the first argument, and it can be a Boolean series. And we conveniently have a Boolean series in mask already. So if I write in mask here, and execute this, I'm going to get those rows that are equal to Sean Connery. And as you might be able to guess by this point, although this result looks exactly the same as what we just saw when we did just the regular square brackets, this is not a copy. This is literally a view of my bond data frame that's showing those rows that have a value of Sean Connery in the actor column. This is not a copy. These are my original rows. So whenever I modify this, I'm going to actually affect the values in my bond data frame. Now what do I want to affect? I want to affect the values in my actor column. So that can be the second argument to my ix method. So I'm going to type in actor here. And I'm going to get, again, a very similar result in terms of visuals to what I just had in the previous example I demonstrated where I didn't do it properly, so to speak. But now, even though it looks completely the same, we're referencing, again, the actor column within my bond data frame where the row value in the actor column is equal to Sean Connery. This is not a separate data frame. This is not a copy. These are just the rows from my original bond. I'm just referencing them. So now if I assign this to Sean Connery, or rather Sir Sean Connery, so we have to have a little bit of change there. Now when I output bond, you'll see that the Sean Connery values in the actor column have successfully been changed to Sir Sean Connery. That wasn't happening when we were using the regular bracket syntax. So again, just be sure you know what you're working with, whether you're creating a copy or not a copy. If you're using that default syntax where you're doing something like bond, and you're doing a Boolean here, like bond actor equals Roger Moore this time. This syntax, when you're just using square brackets, is going to return a new data frame, a copy basically. So when I execute this, we're going to get this result. And the comparison that I showed you was using bond ix. So I'm going to copy this bond series, or rather this Boolean series that's generated here, and pass it below. And we'll see that the result is basically the same. It's exactly the same visually. However, there's a huge difference between using this bracket syntax and using ix, which is the preferred method. This first option, as I mentioned, creates a brand new copy of this slice. So any operations that you do on this copy will only affect the copy. This syntax is a little bit longer. It's a couple, you have to call the ix method, but this will actually affect the values in bond, which is usually what you want to do unless you want to indeed create a separate version, a separate copy to work on. So whenever you're changing multiple values, be sure to use the ix method, pass in the Boolean series as the very first argument, pass in the row, or rather the column that you want as the second argument, or perhaps the list of columns, and then provide the values that you want to give for that column or those columns. So that is how you set multiple values in a data frame based on a met condition.